eagle-eyed amongst you, it's the next day now, this is all glued in, may have noticed that I actually forgot, or appeared to forget, to have put these items back in the turner. So as you can see here, down underneath there now, you can see the white. I've actually gone back and put those in. This is all on. So what we're going to do today is we're going to fix the sliders on here as well. I'm going to show you what I use and how I've made these, because I couldn't find them anywhere because of the unusual size fitting of these shafts. So anyway, let me get set up and we'll make some knobs for this. So as you can see from the picture I'm going to flash up, there is no way that the bottom of these current knobs is going to fit over the top of these. So we have to do some drilling to make them fix. So what I'm using still is I'm using the 3mm drill bit that I brought, and then basically what I'm doing is I'm putting the drill in here as such and drilling a hole, and then I'm opening this up to more this size, and then I've also got a little needle nose file. By needle nose file I mean something like this, which I'm then putting in here, and I'm filing out this to try and get it to sit nicely on the top of here. So it's going to take me a while to do it, but if I just roughly lay this out for you to see, this in theory is what the end result's going to look like. So the knobs are a bit bigger than what I would like, but as I say, at the end of the day, you cannot get knobs for the Turner 5/8. I mean, if anyone knows where you can get them, let me know, but I'm going to run with this. They're black, they match this, they've got a nice white thing on there with a mark, and yeah, that'll do me. At the end of the day, once you set these, you get your mod right, you're never going to adjust them really, are you? So all I'm doing is putting the drill in like so, and I'm rocking it backwards and forwards like this to open that hole, because I've got to be careful that I don't break through either side of here. And it's only plastic after all, so it doesn't take much for it to... So you can see it's opened it up quite nicely. Nope, still wants a bit more, so I'll work on these. I've done this one. That one then fits perfectly on there, gives me all nice slider control, so that's one done. Right. Okay, so I can always put a bit of something on there, but at the end of the day, as I say, it allows me to set them. Once you get them to about there, they're just going to sit there with the knobs on, so one done. Right, I'm not going flush to the... well, I suppose I could go down a bit more, but at the end of the day, you want a bit of a gap underneath. So I'll zoom in and show you how much gap I've got under there. I've got that much gap. It looks a lot wider than what it is actually, but that looks fine. And if you look down from the top, it's on there. So right, let me get the rest of these ready. Right, so I've put a battery in the thing. Let's do the battery test. So you can see the needles moving right over there, which says that we've got a very good battery in, so that's brilliant. So that bit of the mic's working. As you can see, I've got all the knobs on now, so it's starting to look a bit more like a radio. What I'm going to do now is, now I've got the battery in, I've stripped back the mic wires here. I'm going to look at these and just check when I do the push to talk I've got TX and RX, etc. So I'll set up and I'll show you how to check this as well. To do this, you need a multimeter. It doesn't have to be an expensive one. You can get one of these for about £5 to £7 off eBay, and you can measure it by resistance or what they call a continuity test, where you've got an audible beep. But I'll show you both. I'll dig out my old meter and I'll show you it with a cheap meter and also with this that I use, which is a bit more of an expensive one. Right, so here's my 2 meters. This was my original multimeter that I first started with. It's a New Tool DM10, Delta Mic 10 digital multimeter. They're very cheap, and I had this for years, and it's perfectly usable for all CB stuff you want to do. It's a great little meter. I say they're very cheap. I've just turned it on. Unfortunately, I've got a dodgy connection on one of the probes, and to be honest with you, I haven't got time this morning to have a look at it. So what we'll do is we'll use my other one. This one is a Precision Gold PG 017 model. I don't think this is probably about £30. It's not that expensive, but it's a bit more of a professional one. I say you don't need to spend hundreds of pounds on a multimeter. You know, as long as you can measure volts and resistance, that's mainly all I use them for. I don't use it for much else. So anyway, we'll demonstrate with this one how it works, and I'll cover both how you can work with ohms, but also the continuity audible function on it. Oh, you've fallen over. On the meter as well. So I've got on the bench in front of me 2 pieces of wire. Okay, so we're going to set the multimeter. This symbol in the corner here is ohms, so we're going to set it onto the 20M, or the highest ohm settings we can get. We turn it on. When it comes on, it normally comes up with this 0.L. That means it's not reading continuity between the 2 probes. So these 2 probes are not joined, or they can't send one signal to the other. But as soon as you touch them, then you get 0.00, which means they're in contact. So if you get a reading of 0.00 or any reading of like 1.24 or something like that, it's communicating with this probe and this probe. When you get 0.L, that means they're not touching. Touch them together, reading. Okay, so this is where it becomes useful. But on this meter at the bottom here, you can see I've got this speaker symbol here. It's an audible test, and I like this test because all I have to do is, if I've got continuity, i.e. the probe can communicate with the other probe, you get that noise. Hope you can hear that. Let me just move it a bit closer, and you get a reading. When they're not touching, same as before, 0L dot. Okay, so let's put that there. Right, I've got these 2 bits of wire down here on the bench. All right, now the brown wire is one continuous length of wire. So if I touch the probe on this end, the black probe, and the red probe on this end, in theory it's the same as me doing that. You should hear a beep, because unless this wire is broken underneath the outer sleeve, the signal should go from one probe to the other. Let's see if it does. Yes, it does. We've got continuity and a reading of 0.4. Okay. Now, if you haven't got that on your multimeter and you've got the little cheap yellow one, if you go onto the 20M function that I showed you before, got 0.L, and you touch both ends of that wire, and I can probe onto it. Oh, come here. Right, you got 0.00, but again, that means that that wire from one end to the other is a good piece of wire. It's got no breaks in it or anything. So take one probe off, display goes back to 0.L because there's no contact. Put the probe back on, 0.00. Okay, now if we look at this blue wire, what I've done, I've actually cut the wire in half in the middle here. See where it's separated? Now, if you can imagine, we can't see that. That's snapped inside that blue sheath. We can't see it. We've got a problem anywhere in the radio. So we connect onto this end, we connect onto this end as we did before, and it stays at 0.L. That tells you there isn't a connection between either end of those bits of wire. Somewhere in that wire is a break. Okay, and that's what I mean by continuity. The brown wire, continuity from one end to the other. You put a signal in this end, it comes out the other end. Put a signal in the blue wire, it can't come out the other end because it's snapped in the middle. And that's all you're doing when you're testing using the phrase, have I got continuity? Now, the continuity test is also very handy if you want to wire up microphones and work out which is the RX, which is the TX, which is the audio on a microphone, because yeah, you can get those wiring diagrams off the internet, but they don't always tell you which colour wire goes where. Also, likewise on the radio, you can probe on the actual mic pins of the radio itself and then work out which pins of the mic you need to connect to the mic. And I'll show you a quick way of doing it using this meter. Okay, so what I've done, I've connected a crocodile clip to the common, and by the common I mean just the exposed braided copper wire. That's always referred to as common. A bit of research I've done, it appears that the red wire is the relay switching wire, and this has to be connected to ground as well, otherwise the radio won't work. I'm going to just show you this, and then I'm going to go off and I need to do some more checks. So this radio at the moment, if you had the microphone plugged in at the minute, I'm not pressing the push to talk key, which you can see here. So in theory, one of these wires should beep, and that is what's called the RX, i.e. it means it's in receive. So there's nothing on the blue, bit on the black, nothing on the white, and something on the yellow. So let's just an example, if I clamp on the yellow and I'll press the push to talk switch down now, it goes off. Let the push to talk switch back up again, it's back on again. So this black wire also seems to be in receive at the moment. Press the talk to switch and it goes off again. Lift the push to talk switch back up again, it comes back on again. So I would say that the black and the yellow need to be connected together. They are receive. Now there should be one that's got nothing on it, and then when I press the push to talk switch, let's try it on the white one. Nope, nothing. So let's go on to the blue. Right, I'm clamping onto the blue, press the push to talk switch. Now we've got something, let go of it. Come on. You can hear the continuity, turn it off, gone. Okay. Yeah, I'm not happy with... Hello, 1, 2. Yeah, seems a bit odd. Okay, so let's have a look at this then. So we've got the yellow and black, which seem to be RX, or seem to be active on receive. So those two need joining together on the receive pin. We've got the blue, which is inactive on receive. Press the push to talk, then you get continuity. So that's the TX, or the transmission line. And then by a process of elimination, the wire left, which is the white wire, that's going to be your audio. And that's how you basically work it out. Now once you've worked it out at the microphone, as I say, I need to double check these. But the other thing I have noticed, hold on, I'll show you. You can see that the meter at the moment is sitting on the 20. Now you can see it's pegged off, right off the end of the scale. Now it's come back in again, so I seem to have got a dodgy connection somewhere. Yeah, I'm going to have to go back inside and have a look at that. Whether I've got a dodgy joint, I'm not sure. Let me get you a bit closer so you can have a look. So you can see there, I'm sorry it's a bit out of focus, hang on. Try and move you back a bit. So 1, 2, 1, 2. Now notice it's pegged off to the left here below that line. Watch what happens a couple of times. There you go, it's back on again, but 1, 2, 1, 2. So I think we've got a dodgy connection somewhere. So again, from its rough trip, does the battery test work? Yeah, that works. Let me get its peg off the end. Yeah, it's gone off the end. Battery test still works, it takes it back. So it's definitely something not right. But if we go into transmit, 1, 2, 1, 2, hello, 1, 2, 1, 2, testing, 1, 2, 3. So it does appear to work, but I've got that dodgy connection, so that's something I've got to look at. Whether that's something to do with the wiring, I don't know, but we'll look into that, see what we can come up with.